Okay, this is section 3.2 in your textbooks. We're starting this textbook a little bit out of order because we think the skills in chapter 3 will help you when we go back to chapter 1. All right, so we're going to start in chapter 3. At the beginning of certain lessons, we have an investigate. We won't always do the investigate, but sometimes we will, okay, depending on its usefulness. Okay, in this particular lesson, I don't feel that the investigate is that useful, so we're going to skip it. So we move right down to this section here. It says a power is a product of identical factors and consists of two parts, a base and an exponent. So it's important to understand that this whole thing here is a power. Okay? Some people might say, or you might have heard before, 2 to the power of 4. That's incorrect. Okay? That's incorrect mathematic terminology. All right? This is read 2 to the exponent of 4. Okay? This is the exponent, the small number on top. The bottom number is called the base, and the whole thing again is called the power. Okay? This is called exponential form when we have it written as a power, and this is called the expanded form when we have it written out. Okay? Any questions about that so far? What a power is? Yes?
What would you name that specific power though? Like,
you would say 2 to the exponent of 4.
So it's just all of them are just called powers? Like,
yeah, this is a power, this is a power, this is a power. Okay? All right? Okay. Joseph, can you close the door? Okay, so we're going to look at a couple of quick examples. It says, write in expanded form and then evaluate. So, as we learned, the exponent tells us how many times we need to multiply the base. All right, so here we have a base 2 to the exponent of 5. So that means we're going to multiply the base 2 5 times by itself. So 2 times 2 times 2 times 2 times 2 is 32. Okay? So that's how it's written out in expanded form, and that's how the answer. That's how the answer is. Okay? If we look at B, same idea. If it's negative, that negative needs to be multiplied as well each time. So that negative is included in brackets, -3 times -3 times -3. Exponent is 3, we multiply the base 3 times. Exponent is 4, we multiply the base 4 times. Notice how any negative number that is raised to an odd exponent is going to result in a negative answer. Okay? Any negative number raised to an even exponent, because negative times a negative is positive, it's going to result in a positive number. You guys see that? So you should be able to recognize that either by writing it out in expanded form or just knowing that when a negative number has an even exponent, my result is going to be a positive number. When it has an odd exponent, my result is going to be a negative number. Okay? The difference between this -3 to the exponent of 4 and this -3 to the exponent of 4 is very, very important, okay, between these two. Maybe the most important thing in this lesson is that you're able to recognize the difference between these two powers, okay? When the negative sign is in brackets, like this, okay, that means that negative sign is actually being raised to that exponent as well. So you include it in the base each time. When the negative sign is not in brackets, it's not included in that exponent. So it stays on the outside. It stays on the outside negative, and you just raise that positive base 4 times. You multiply the positive base 4 times. So did you notice that? See how that negative sign, because it's not in bracket, it just sticks on the outside here. And then whatever happens with the power, with the base, stays inside the bracket, and that negative sign stays there. Okay, that's very important. Because as you can see, the difference between bracket -4 raised to the exponent of 4 and -3 to the exponent of 4, not in brackets, is very different. One is positive 81, one is negative 81. Any questions about that? Okay, so again, if it's in brackets, you're going to include it in the base and multiply it. If it's not in the brackets, you leave it on the outside and deal with the exponent. Okay? That's very important. Here we have decimals, exact same idea, just using your calculator, multiplying 3.5 times itself 3 times. And here we have fractions. When we have a power to the fraction, you're going to multiply the numerator and the denominator by that exponent. Okay, so this 2 over 3 to the exponent of 3 is the same thing as 2 to the 3 over 3 to the 3. Okay, so that exponent in a fraction, it belongs to both the numerator and the denominator. Does that make sense? You have to use that use that exponent to both the numerator and the denominator. All right. Here we have example 2. So very quickly here, this is a volume question. It's asking us which container has more volume. Okay? The first one is a cube. All sides are the same length. We know the formula for volume of a cube is what? Yeah.
Base times height times width.
Right, base times height times width, or another way is length times width times height. That's how I typically think of it. Okay? So here we can say our length is 9.2, our width is 9.2, and our height is 9.2. So we can get our volume as 9.2 cubed. Okay? We get our answer on our calculator. For a cylinder, who knows the equation for the volume of a cylinder? Salvatore?
Pi r squared times height.
Very good, yeah. So it's just the area of the circle, right, which we know is pi r squared, times that height. That's how you get the volume of a cylinder. Okay? So again, we would use these dimensions. Pi r here is going to be 5.2 because it's half of the diameter. And our height is 9. Okay? So if we were to multiply both of those out, here's our volume for the mega box, 9.2 cubed, 778. And our volume for the drum is 764. So we can subtract them to know the difference that we would get in popcorn. Any questions about that one? So the only trick there were the two volume formulas. All right, so finally, very quick lesson here. Our key concepts. Powers are a useful way to express repeated multiplication. For example, 4 times 4 times 4 is the same as 4 cubed. A power consists of a base and an exponent. In red is the base. 4, the exponent is in blue. So it tells you the identical factor, and the exponent tells you how many factors there are. So in other words, how many times you're multiplying. Finally, powers sometimes appear in formulas. When evaluating expressions involving powers, follow the correct order of operations. So of course, order of operations, we're going to follow BEDMAS. So our exponents come very early, right? They're going to come second, right after the brackets. Okay, so they're the ones that we look at second. Any questions? Very basic lesson. I don't imagine many of you will have problems with the homework. Okay? Again, we're not going to start it tonight. We'll start it tomorrow in class. Any questions with that lesson?